All right, just a little bit of background. Just following on from what Rick just said, there's been a number of local, predominantly funded by Forest and Wood Products, but as well as that, a lot of international studies that highlight the lack of timber usage, particularly in the non-residential building sector. And that sector is currently worth about $16 billion a year to Australia. These studies have identified that there are potential opportunities to improve the market share for timber. At the moment in Australia, that market has been effectively hijacked by the steel and concrete industry, which, as we all know, are very environmentally friendly materials, particularly if you go out to Western Australia and have a look at the big hole in the ground. And it really frustrates me that so much of what we're trying to do in terms of, I believe, meeting a legitimate national need to develop a green building material gets hijacked by the green movement. It's just dumb. So what we're trying to do is identify and create some enablers through research, tapping into the international research community so that we can create the technical opportunities or the technical enablers to increase the market share. But there's a number of obstacles that we've got to address to realise that potential. Just to give you a little bit of context for residential construction in Australia, now what's interesting in this timber, if you're particularly on the east coast of Australia, a lot of the standard sort of single dwelling and medium dwelling is timber frame construction, but the amount of timber in those buildings is relatively small in terms of the cost and the return on it. It's significant, but it's not a big proportion of that $30 billion. If we move into the commercial and industrial sector, whilst the total dollars aren't as high, the amount of timber that could be potentially used in these buildings is significantly higher and therefore has a significant value potentially in the market than what we're doing with residential construction. So we've got these opportunities. And there are a few drivers for this, particularly if you live in Sydney or Melbourne. There's been a decentralisation in employment away from CBD areas to inner precincts. In Sydney at the moment, we have a number of inner city precincts that are being developed around multi or higher density residential construction combined with commercial facilities. The demand for high-rise CBD in the high-rise CBD office spaces is reduced, and this means that there's more low, medium-rise buildings, and this presents opportunities for structural timber. And we're getting this feedback from a lot of the developers. It's not just something that we've made up. And as I said before, the structure in these buildings is a larger proportion of the construction cost, which opens up potential for a larger amount of timber use. That gives us the potential ability to value add. So I want to take up one of the points that David said, that a part of the value adding process is actually linking it with smart manufacturing techniques in such a way that we can value add not only for the Australian market, but if you looked at one of the potential drivers in China, there is a huge potential for us to actually, instead of selling saw logs or sawn timber to China, to actually sell building systems to China that will address their public housing priorities. And so we've got to look at how we could maximise gross margins through integration of fabrication design to develop building solutions rather than just sell products. As I said before, the steel and concrete products are well established and accepted in this marketplace, and they fight like tooth and nail. They will not give up their share easily. The market is highly competitive. So timber won't be able to increase market share without targeted investment in both R&D and the value-adding side of it, but the potential of this is somewhere between $0.5 and $1 billion per annum, so it's not insignificant. Now, there's a need, obviously, to develop efficient and innovative engineered products and systems for application in these types of buildings. And one of the things that we've learnt in Australia is that we don't try and reinvent the wheel. We try and look for where innovation is occurring overseas, and then we try and tap into that as best we can. What we've learnt is that there's a need to develop structural building systems that can take advantage of prefabrication manufacturing techniques and precision. It's no longer good enough to be, it's close enough sort of thing. It doesn't work when you go into the commercial arena. The products have to be commercially competitive to construct, but we're not looking at the sale price of the thing itself. We're looking at the finished installed price of the building and the value that's created in that. And it has to meet the relevant performance criteria. So that will be structural, but it also has to do with occupational safety and comfort, fire and durability, that's a part of non-residential. So the next number of slides are just to stretch your imagination so you can see that the things that I'm talking about are actually happening today, particularly in Europe, but also in other parts of the world. So we've got things like 7-storey timber buildings in Berlin. This uses a similar flooring system to what we've developed at UTS that is a concrete timber composite, but we're also developing timber-only solutions. One of the glue lamp CLTs, I'll use the term CLT, it's cross-laminated timber. It's essentially like a plywood type product where we've got cross plies, but they're made of small bits of timber, and they're able to utilise parts of the log that are currently not particularly economic to process. So in terms of getting increased log yield, some of these types of products have enormous value, and they can use very low-grade products selectively to come up with a high-performance engineered product. Again, 4-storey, this is becoming quite common. This is in Espoo in Finland, Munich. KLH is one of the big CLT manufacturers in Austria. And you can see the photo on the right there actually shows the CLT product. If you look at it carefully, you can see small bits of timber, and they're literally crisscrossed to form this particular type of panel. All of those panels are prefabricated. They're cut with CNC machinery, and so the type of plant that's been developed is a one-stop shop. The sawn timber billets come in at one end, and out goes the finished building product. This particular building, known as the Murray Grove Residential Building, was one of the big step forwards, if you like, in the UK market. It's all made out of CLT timber, and Forest and Wood Products sponsored Andrew Waugh, who was the architect for this, and if you ever have the chance to hear Andrew talking about this, it's well worthwhile, because he talked about the fact that he as an architect was passionate about timber, and I won't use the adjectives that the building developer used, but the thing that got him interested was not timber, but was the fact that he saved a fortune in on-site crane haulage, and this building went up in record time. A number of the trades, instead of being on site for 6 weeks, were on site for 2 weeks, and it ended up being a high-quality, highly cost-competitive product that creates a breakthrough for public housing in the UK. And so we're seeing this moving now into more commercial and educational type precincts. Again, lots of use of timber, and these are large buildings. And 10 years ago, this would have been built out of probably precast concrete. And in Australia today, it would probably be built out of precast concrete. Canada, as you know, is one of the great wood exporters, and they've got a similar project to the STIC project that Rick alluded to. It's an incentive. They call it the New Builds project, and we are closely aligned with that. So there's a technology exchange, and we're actually making sure that we're not replicating research, we're complementing one another to help one another develop new building systems. Now, a little bit closer to home, the STIC project, I'll talk a little bit about that in a moment, but it's had some fairly sharp imperatives. Some of them come from Rick himself, that we have to produce runs on the board. We have to get runs out there. It's no good just doing a lot of research and then we've got all these reports and it sits on a shelf somewhere. So one of the first buildings that utilised a lot of this technology is the NMIT building in Nelson, which is basically a tech college. And you can see there that it's a 3-storey building. And this is in a seismic region, so it's using a lot of engineered wood products, and we've learned a lot from it. We've learned a lot of things that you shouldn't do, and one of them is have a traditional construction contract, because everybody blames everybody else and we never find out what the actual costs are. So we need new business models for these types of buildings. More recently, there's the Moat building, which is the aviation hall in Auckland. It's a huge building, 3,000 square metres, 42 metre spans, 15.8 metres high. Now, what you don't realise when you see that portal frame in the bottom right there, they've got planes hanging from them. So they're not just sitting there holding the roof up. They've got really substantial loads. And it's a good example of what you can do with engineered wood products.